Artificial intelligence is pretty much everywhere now. It's powering our businesses, it's shaping our lives. But with all that incredible power comes a whole new set of dangers. So, in this explainer, we're going to dive deep into the world of AI security to figure out how we can protect these smart machines that we rely on so much. Okay, so first things first. To really get a handle on the problem, you have to understand the sheer scale of AI's takeover in the business world and the massive blind spot that's come along with it. I mean, companies are betting big on AI. Get this, by 2025, we're talking about enterprise spending hitting a mind-boggling $200 billion. This isn't just some side project anymore. AI is literally being woven into the very fabric of how global business operates. But here's the catch. While all that money is pouring in, the price for getting security wrong is absolutely catastrophic. A single data breach that involves AI costs, on average, almost $4.5 million. That's way more than your typical old-school breach. And this is exactly why we can't just use our old security playbooks. See, traditional software is deterministic. It just follows a set of rules very predictably. But AI, well, AI learns. It makes predictions. It's probabilistic. And that very nature, its ability to think, opens up a whole universe of brand new vulnerabilities that things like firewalls were never, ever designed to stop. So that leads us to the big question, right? What are these new ways to attack a system? I mean, what does it even mean to hack an AI? All right, let's get into the nitty-gritty. In this next section, we're going to look at exactly how attackers are going after the learning part of AI systems. And they're doing it in some really clever and, frankly, often invisible ways. So first up, you've got something called adversarial examples. The best way to think about this is like an optical illusion, but for a machine. An attacker can make these tiny, almost imperceptible changes to something. Let's say they put a few specific stickers on a stop sign. To you and me, it looks totally normal, but to a self-driving car's AI, it can cause it to completely misread the sign. Scary stuff. Then you got data poisoning. Okay, so if an AI learns from data, like a student learns from textbooks, data poisoning is like an attacker sneaking into the library and secretly rewriting pages in those books. They mess with the training data to teach the AI the wrong things, maybe create some hidden biases, or even build secret backdoors that they can use down the road. And this is a big one, model extraction. This is basically pure digital espionage. For a lot of companies, their AI model is their most valuable piece of intellectual property. It's their secret sauce. Attackers can steal it, not by hacking a server, but just by asking the model thousands of questions and then reverse engineering how it thinks based on the answers it gives. And this isn't some random attack. It's a full-on heist. It's methodical. First, the attackers do their reconnaissance to scope out the target. Then they try to get access. After that, they start querying it over and over to extract the model's logic. And finally, they replicate the stolen model for themselves. It's a planned operation. Okay, so the threats are real and they're really sophisticated. So how do we fight back? Well, it means we have to build a totally new kind of digital fortress. This slide just lays it out perfectly. It's a whole new battlefield. Our old tools, firewalls, antivirus software, they're still important, but they're just not enough anymore. Securing AI demands a completely new toolkit that's focused on things like making sure the model has integrity, actively hunting for data poisoning, and even training our own AIs with those adversarial examples to make them tougher. A huge piece of this is just controlling who gets to touch what. It's called the principle of least privilege. A data scientist, sure, they need access to build the models, but a regular business user, they only need to be able to ask the final model a question. By locking down these roles, we shrink the potential attack surface in a massive way. We can also get incredibly clever with how we handle the data itself. There are techniques like differential privacy, which adds a kind of mathematical noise to data to protect people's identities, or federated learning, which lets a model train across thousands of phones without the sensitive data ever leaving those devices. There's even homomorphic encryption, which lets you do math on data while it's still encrypted. The big takeaway here is that we can build powerful AI without ever having to expose raw, sensitive information. And all these different defenses, they're all leading to one powerful idea: zero trust. See, in the past, we kind of trusted anything that was already inside our network. Now, the new rule is to assume a threat could be anywhere, inside or out. So every single request to access data or use a model has to be verified every single time, no matter where it's coming from. Trust nothing, verify everything.
But listen, all the best technology and architecture in the world is only part of the solution. The strongest and, let's be honest, sometimes the weakest link in any security chain is always the people.
This is why security training can't just be a one-size-fits-all email that nobody reads. It has to be tailored to the person's job. Your developers need really deep technical training on how to code securely. Your executives need to understand the big picture of risk and governance, and your regular business users just need to know how to use the AI tools safely. Everybody has a part to play. And this, honestly, might be the most crucial piece of the whole puzzle. You have to build a culture where any employee feels safe enough to raise their hand and say, hey, this AI is acting kind of weird, and they know they won't get in trouble for it. That early warning from a person is often the fastest way to catch a really sophisticated attack in its tracks. At the end of the day, AI security isn't a project with a finish line. It's not a box you can just check off and be done with. As this quote puts it so well, it's a journey. It demands constant vigilance and adaptation because you can be sure that the attackers are constantly learning and adapting too. And that leaves us with one final and pretty critical question. We're heading into an era where the bad guys are going to use AI to create their attacks. So as this new technological arms race heats up, will our defenses, our tech, our plans, and most importantly, our people, be enough to keep us one step ahead?